All right, so these problems will kind of be like how we finished the sum and difference formula problems, where you'll be given a ratio for one trig function, and you use that to find the double angle for any of the other trig functions. All right, so you see this 2 theta. This is basically saying what would the exact value be of some angle if you double it. That's what the 2 theta means. So we double all these angles, we have a formula to figure out what the exact value is. All right, so they work kind of similar to the sum and difference formulas, where once you get the exact value, you just replace the exact value of the given angle in the place that you see, and you simplify it and you get your exact value. It's really not difficult. Tangent, like all the tangent stuff, it's just a little bit more tedious. And this one we got a fraction, so it's just a little bit more mathy, where we have to simplify some fractions, but other than that, it's pretty straightforward. So we got 3 different formulas, and each one's a little bit different. In all honesty, sine and cosine are pretty straightforward. Shouldn't take you long to do it all. Tangent will take a little bit more work. And you see this one for cosine, it's very long because there's multiple ways you can use the formula for cosine. There's actually 3 different formulas you can use to get the exact same answer. The one that I did a box around is the one that I'll always use, just to try to be consistent. And I think it's the easier of the 3 options that you have. But if you're somebody who asks Alex to work this problem for you, or you go on like Khan Academy and watch a video, you might see one of these other formulas being used. Don't freak out. Just wherever you were looking, they might have choose to do a different problem. I'll always do this one just to be consistent, and I think it's the easier one in most cases. But just a heads up, you can see any of these other ones. But you don't have to do all 3 of these. We'll just do the one with the box in. All right, so let's look at this first example. And we're only going to do 2. I think that'll be all we need. We can do some more if we need to, but it says we're given that sine of theta is 7 over 25. And it tells me that theta is in quadrant 2. And then we want to find, and I think I deleted sine when I made this, but it should be sines double angle, cosines double angle, and tangents double angle. So we're going to find the double angle for all 3 of these functions based on this situation that we were given. All right, so it tells me this angle is in which quadrant? 2. So I'm going to go to quadrant 2 and I'm going to draw an angle. I don't know what the value of this angle is, but I don't really need to know it. I do want to be able to use these ratios and label an angle in this quadrant. Okay, so I draw an angle in this quadrant. I'm going to turn it into a right triangle by going straight to the x-axis. My reference angle is here. What is sine's ratio? So, what's sine's ratio? Opposite over hypotenuse. So the opposite side would be 7. The hypotenuse would be 25. So let me go over here and label those sides accordingly. The side opposite of the angle would be 7. The side across from the right angle is the hypotenuse. That would be 25. Everybody okay? So we've been given 2 sides of this triangle, or this situation. We don't know one. Some cases you might not need the 3rd side, but if I go and look at the formula for sine, I'll need to know what cosine's exact value is, and I know cosine is which 2 sides. Yeah, so I'll need to know the adjacent side. So we got to find this missing side. But once I do that, I'll be able to get all the pieces that I need. So we got H, we got O, we need to find A. Any ideas how we'll find A, the adjacent side? Pythagorean theorem. I'll tell you, this is a Pythagorean triple, meaning this is a whole number. It's a 7 something 25 right triangle. 6? Not 6. We'll do Pythagorean's theorem, but going forward, maybe you'll throw this in the memory bank and you won't have to do Pythagorean's theorem next time. Just be able to do it. So Pythagorean's theorem, a squared plus b squared equals c squared. C squared is always which side? The hypotenuse. And I think that pen is fading on me, so let me switch. So I'll do 7 squared plus b squared, which is the side I want to find, equals 25 squared. What's 7 squared? 25 squared? 625. And look, you would just do this in your calculator. Don't freak out like you gotta know this or remember this. You just put these numbers in your calculator. Then I'll subtract what from both sides? The 7 squared, 49. And I get 576. And then I will look to do the square root of that. And I'm hoping to get a whole number. And I do. It's 24. So the adjacent side is 24. So now I got all my sides. I can find all of my ratios that I need. So we were given sine. Let's see what cosine's ratio would be. We said cosine was A over H. Adjacent side 24. Hypotenuse 25. So cosine is 24 over 25. Should this 24 be negative in the second quadrant? It should, because we go left 24, we go up 7. So this 24 should be negative. And cosine should be negative in the second quadrant. So I'm going to make that ratio negative. And then while we're here, let's go ahead and do tangent, because we'll eventually need tangents ratio as well. So tangent is TOA. Which two sides represent tangent? Yeah, close. Opposite over adjacent. TOA. O over A. Opposite side is 7. Adjacent is negative 24. All right, so we got all our ratios. We got sine, cosine, and tangent ratio for this angle. Okay, so we're going to find the values we get if we double it. Everybody good so far? All right, so first one, let's do sine's double angle. All right, so just to be clear, I'm just going to follow this formula. I get 2 times the ratio for sine. What did we say sine was? It was given to me. Yep, opposite over hypotenuse. That was given to me, 7 over 25. Times cosine. Cosine we found was negative 24 over 25. So I just multiply top of the fraction, multiply the bottom of the fraction, and I get my exact value. Right, so 2 times 7 times negative 24. Negative 336. That's the top. And then just to be clear, since this is just 2, it's not 2 over anything. I guess it's 2 over 1, but this would be in the numerator. So I multiply all the top numbers, then I'll multiply all the bottom numbers to see what I divide by. 25 times 25, we actually already did that. 625. And this is the exact value for the double angle. And I don't really have to try to reduce, because if I could reduce, I would have been able to reduce like somewhere here. Like I would have said, oh, 24, 24, those cancel out. But I don't have anything I can reduce here, so I won't be able to reduce anything here. All right, any questions? Okay, let's go to cosine's double value, double angle. So we're doing 2 times theta. So I'll follow the boxed formula. Like I say, you could do any three of these. I'll just always do this one just to be consistent, so we can get used to just using one of them. So I'll take cosine and I'll square it. Cosine is negative 24 over 25. I'll square it. Then I'll subtract what exact value squared. What comes next?
Minus sine squared, right?
Yep, sine squared. So sine was 7 over 25. And I'm going to square it.
That should be.
So as the numbers get big, don't let that scare you. Just use your calculator. Negative 24 squared or just 24 squared, because it's going to come out to be positive, gives me 576. On the bottom, I have 25 squared. And just remember, whenever you square a fraction, you square the top number and you also square the bottom number. So here I would do 25 squared. We already did that, didn't we?
625.
Yes, sir. Minus 7 squared, what's that? 49 over 25 squared again, which was 625. Do I have the same denominators?
Yes, you do.
I do, so I can just subtract the two top numbers. 576 minus 49, and then I got my answer. 527 divided by 625.
So the other part of that formula, the 1 minus 2 sin squared, are we ever going to use that in this?
Like I say, you can choose whichever one of these three you want to do.
It's not a formula.
It's just a formula. It's just a different way the formula works. So I won't show you how, like, where did this formula come from? I won't do all that. But if we did all that, there's 3 different ways you can do this formula.
All right.
I'll just do this one because I think that was pretty easy.
I don't know.
But if you like, I don't know, maybe you want to do the one of the other ones, feel free. By all means, feel free. All right, so we did sine and cosine. One more to go. Any questions yet? All right, so let's do that one. All right, so tangent's double angle. So we're going to follow this formula right here. So I started off, excuse me, 2 times tangent. And we already found tangent's ratio to be 7 over negative 24. Oh, and just heads up, in the last classes we did note checks, and it was an easy daily grade for just paying attention and doing your notes. So probably we'll do that again today. All right, so 2 times tangent, got that, and then I divide by 1 minus tangent's exact value squared. So I have this same ratio. And I square it. So this is my answer. Obviously, we got to do some simplifying, but this is my answer. At this point, it's just simplification, which is a little bit more tedious because we got a couple of fractions here. Everybody okay so far? All right, so just to kind of do some foreshadowing. At some point when we end up keep change flipping, if I don't cancel these 2 numbers together to start off with, it'll make cancellation easier at the end. I'll show you when we get there, but long story short, we're not going to simplify these 2 just yet. I'm going to just go ahead and do 2 times 7 to give me 14. So on the top, we got 14 divided by negative 24. And then in the bottom part, we got 1 minus 7 squared, 49 over 24 squared. We already did that one before, didn't we? Yeah, right here. What was 24 squared? 576. All right, everybody okay? So now what I want to do is get these two numbers in the denominator to be just one fraction. In order to do 1 minus this, I need a common denominator of 576. So I just need to rewrite how the 1 looks. If I change 1 to be 576 over 576, I'll be able to subtract these two. So in this next step, when I come over here, that's what I'm going to do. I'm not going to change anything on the top just yet. So 14 over negative 24, all divided by. And I want these two to come together. So I'm going to rewrite 1 as 576 over 576. Because that's just 1, right? And now I'll be able to subtract 149 from it. Everybody okay with what I did there? So now we can subtract these two. 576 minus 49 equals 527. So 527 over 576. Can you guys read all that? I know it's small. I'm getting tight on space. You got any questions? And we're getting closer.
Can I see that whole like bottom left part?
This part?
Yeah.
Yeah. All right, so we're dividing a fraction. How will we divide a fraction? What do we do? Keep, change, flip. So we're going to keep the top. I'm going to change my color so it doesn't look as jumbled. But we got the top, which is 14 over negative 24, times, and then I flip the bottom. So 576 over 527. And now what I was saying is you'll be able to divide this number by this number. This number will cancel out because we didn't cancel at the beginning. So 576 divided by 24 equals 24. So I can completely cancel these two numbers out, or this number out, to be negative 1, and then this one becomes 24. And so now to get my answer, I'll just multiply across. So I've got 14 times 24. How did these two cancel? I'll do it again. 5, because these two are dividing. So I can multiply all this together and then figure it out. But it's kind of easier if I see if it cancels out before. So just 576 divided by 24, and I see, oh, I can actually cancel out this whole number.
Okay.
Does that make sense?
Yeah, that makes complete sense. So it's just square root.
Okay. All right. And then I have negative 1 times 527. And that's my exact value for tangent. Okay. All right. So, I mean, it's not complicated stuff. It's just tedious. For this, I would say show your work. Try to be neat and keep everything somewhat in line, and organized, and it'll take some of the stress out of this simplification. All right, so we found what the exact values of these three double angles will be. You guys have any questions yet? All right, so let's do this last one. Feel free to work ahead if you just want to take a shot at it, or you got it. And stop me if I'm going too fast or something's not making sense. All right, so similar situation. We want to find the double angle for these three functions, and this time we're given that cosine of some angle theta equals -2/5. And then it says theta falls in between these two radian measures. So we got to figure out where we're going to draw this angle at. So it tells me theta is greater than pi. Where is pi at?
No, it's 180.
180. So right here, pi is right here. And then it says it's less than 3 pi over 2. Where is that angle at? The bottom one, 270. So just to interpret this angle falls in between these two sides. So yeah, it means it's somewhere in quadrant 3. We don't really care where it's at because we're going to use the ratios anyway. So I'm going to draw an angle in quadrant 3. I'll make it into a right triangle by going to the x-axis. And then I'll use the information I was given to label the sides. Cosine's ratio is what over what? Adjacent over hypotenuse. So that's the two sides I'm given. Adjacent is 2. The hypotenuse is 5. Should one of these be negative in the third quadrant?
Yes.
Which one? The 2. Because I go left 2. Don't know the y, that's what we need to find, but will y be negative or positive? It'll be negative because we go down. The hypotenuse or the radius is always positive. Because if you square both numbers, you'll get a positive number, and it's always bigger. So this is always positive. If you made this -2, then this number would be positive. So something has to be positive in this case. The hypotenuse is always positive. All right, so we got adjacent. We got the hypotenuse. Let's find the opposite side. Right, so Pythagorean's theorem again. I'll do a squared -2 squared plus b squared equals 5 squared. 2 squared is 4. What's 5 squared? 25. I subtract 4 to get 21. And then I take the square root of both sides. And I get the square root of 21. Can I get a whole number from that?
I don't think so.
I can't. You're right. So I leave it as the square root of 21. Don't write, what would it be, like 4 point something? Because you get like not an exact value. So just to try to explain this, if I did the square root of 21, I get this long decimal value. Do you want to write all these numbers as you start to do your work? I wouldn't. And you can't round it because then it won't be the exact value. It'll be an approximate value. So you just leave it as the square root of 21. So that's what my opposite side is. Okay, everybody okay? So let's see. We got cosine. Let's find sine's ratio now that we know all the pieces. Sine would be opposite over hypotenuse. What's the opposite side? Root 21. Oh, and it's -21, right? negative root 21 divided by hypotenuse. What's the hypotenuse? 5. And then we need tangent. Tangent is TOA. We said O was negative root 21. What was A? Negative 2. Negative divided by a negative makes it positive. So that number is going to be positive. You remember all students take classes. Take is for T. Tangent. Tangent's positive in the third quadrant. So that makes sense. All right, you guys take a second. See if we can find the double angle for sine. So we got all the pieces we need. You're just going to use this formula. 2 times sines ratio times cosines ratio. And just going to multiply all your numbers together. Let's see if we can do sine. So you do sine times cosine times 2. So 2 squared is 4. Square root of 21 squared, it cancels out the radical, and it's just 21. Since they both had a denominator of 5 squared, 25, I just went on and wrote them as one fraction. You can write them as 2, that's perfectly fine. You get the same thing. I just went on and did it as 1. So 2 times what?
Would it just be the opposite over adjacent?
Yep, opposite over adjacent.
Or is that 21 over 2?
Yep, root 21 over 2. Good job. Root 21 over 2. And then I follow the formula. So divided by 1 minus that same fraction squared. So 1 minus root 21 over 2 squared. Now this one's nice. Since both of these numbers will cancel out, I'll go ahead and cancel these out. And it gets rid of one of my fractions, making my life a little easier. I just need to simplify the bottom. Everybody okay with where these numbers came from? All right. So I'll go ahead and cancel these 2 out, leaving me with just root 21 in the numerator on the top. Then I got 1 minus, what was root 21 squared? Just 21 over 2 squared. 4. To get these together, I need a common denominator of what? 4. So I'll rewrite 1 as 4 over 4. Then I can subtract these 2 numbers. So 4 minus 21, 17 over 4. And since I'm dividing a fraction, I'll keep change flip to finish this problem. So I keep the top, it's just the square root of 21. And you can write divided by 1 if you want, but it's just the square root of 21 times 4 over 17. Do I need any negative signs or anything? Tangent was positive, positive. Yeah, this should be negative. This should be negative, right? So this should be negative. So my answer should be negative 4 root 21 over 17. Alright, so as you finish getting that, normally when you like get these questions, you'll only